Hello again, this is Ms. Fallon. Some classes I was able to go all the way through the homework, which was this page, if you remember, called Practice 8-3. And some classes I wasn't able to get through and explain it the way I wanted to, so I thought I'd make a quick video. All right, so this is a good compilation of all the things that you kind of need to know for similar triangles for the midterm. So it'll be good to go through this. If I look at the directions at the top, first, when it says explain why they are similar, the first thing I want to think of is my answer needs to be either AA, SAS, or SSS. So that's the first piece they want. They didn't tell me to decide whether or not they were similar. They said explain why they are similar. So I am going to go under the assumption that problems 1 through 6 show all similar triangles. And I have to tell which method they used to prove that. And then after that, I have to write a similarity statement, which in my mind looks like triangle such and such is similar to triangle such and such. So there's going to be 2 pieces to my answer. So let's look at number 1. In number 1, I see some triangles stacked on top of each other, connected at a vertex, and it looks kind of like a bow tie or an hourglass or something. So one of the things I see first is a couple of congruent angles that are already marked. I don't see any side information, so I'm wondering if this is AA. Because I don't see any lengths of sides given where I can come up with proportions to compare. All I see are a couple of angles marked. Looking a little closer, I'm always on the lookout for vertical angles, because vertical angles are congruent. So I'm going to mark that in my diagram. And now I can see, yes, indeed, this is the AA similarity postulate. Which 2 triangles are similar? Well, I'll start off with naming the top, ABX, good alphabetical order. And then when setting up my second triangle, I look to see what coordinates with angle A. Angle A has the blue swoopy angle, and so does R. So I know R corresponds with A. That must mean that the X's coordinate. So I know my X is going to go at the end so that it coordinates with the X of the other triangle. And so that means Q needs to go in the middle. So my entire answer for number 1 is the AA similarity postulate, and those 2 triangles are similar to each other. Number 2, I have 2 triangles. They're both right triangles, and so right off the bat, I notice I have some right angles, and that means that they're congruent. So that's always good to know. I don't see any other angle information, so I'm ruling out AA. I'm wondering if it's going to be SAS or SSS. So let's start with SAS, since I already have a pair of congruent angles. And let's see if we can match up the sides that are on either side. 9 is the smallest of the 2 sides of the right angle, so it's going to correspond to the 12. So I'm looking at 9 over 12. Then I see the other side of the right angle is 12 and 16. So I'm going to look at 12 and 16, and I'm going to see if these 2 ratios actually equal the same thing. So you can either put both of the fractions into your calculator, 9 divided by 12, see what you get, 12 divided by 16, see what you get, and see if they equal. Let's see, there's a couple of different ways you can do this, but since the numbers are quite simple, I'm just going to simplify each fraction. If I divide top and bottom of 9 over 12 by 3, I can simplify this fraction to 3 over 4. If I divide top and bottom of the blue fraction, 12 over 16, by 4, it will simplify to also be 3 over 4. So guess what? These sides are in proportion to each other. That means I have similar triangles by SAS. Good to know. But I also see that there is another set of sides labeled and everything, 15 and 20. So I'm kind of curious. Is 15 over 20 also going to simplify to be 3/4 if I divide top and bottom by 5? We find out that it does. So not only can we prove these two triangles similar by the SAS similarity postulate, we can also declare them to be similar by the SSS postulate. So that's kind of fancy. I am going to, where should I write this? There's not a lot of room on here. I'm going to go ahead and get rid of my work over here, clean it up a little bit. Now that we've done all the work for it, I'm just going to go ahead and put the two answers. So yes, SAS or SSS work. And I have triangle, let's call it, if we're doing alphabetical order, it would be MPX. It is similar to triangle, what coordinates with M. Well, M is between the smallest length and the largest length. So the smallest length and the largest length here is L. P is the right angle, so I know that coordinates with W, and then what's left over in the bottom triangle? Point A. So my whole answer here is that. Kind of nice if there were two different methods I could use. Moving on to number 3. Number 3. I don't see any angle information yet, but I have been trained to look for vertical angles, and there they are. So I'm wondering if this is SAS. I look and see, let's see, 4 is smaller than 8 in that triangle, so I'm going to look for the smaller of the two over here, and it looks like it coordinates to the 2. The 8 in the left triangle coordinates with the 4 in the right triangle. So let's form my ratios, 4 over 2, and I want to know if that's going to be the same as 8 over 4. And yes, they both reduce to be 2 over 1. And so the sides are in proportion to each other, and the angle between is congruent. So these triangles are congruent by SAS, and it's triangle, is that an O or a Q? Let me erase, there it's a Q. Triangle MPQ, alphabetical order, is similar to what coordinates to M, but itself. And P coordinates with B, and Q coordinates with A. Continuing on, number 4. There's no side information given, but lots of angle information. At first glance, I can match up the 30 with the 30. And then I get a little discouraged because I see 20 degrees and 130 degrees, and I think, oh, maybe they're not similar. But wait, the 20 degrees is pointing down to this angle, where the 130 is pointing to the obtuse angle in the other triangle. So if I use my rule of the angles of a triangle add up to be 180 degrees, I can subtract 30 and 20 together, which make 50, and I get 130. So looky there. So now I do have 2 sets of congruent angles, and therefore I have 2 triangles that are similar. I covered up this vertex, it's a J. So JMN is going to be similar to what coordinates with J, but the other obtuse angle. C is obtuse, And what coordinates with M? That's the 30-degree angle. So that's A. And then that leaves B at the end. And so there's my similarity statement. Number 5. Oh, tricky. Well, I might as well go ahead and mark my vertical angles because that is something I'm always looking for. So I'm suspicious that it's SAS again. But these tick marks here, these hash marks through the sides, really confuse me because I need to set up some fractions to see if there's a ratio, if the lengths are proportional to each other. So how about if I put some just dummy values in? How about 8 and 8, and I don't know, how about 3 and 3? Because they do have to be congruent to each other. That's what the tick marks mean. So I just chose numbers, and once I chose a number, I had to make sure that they matched up. So now I can use these dummy numbers and see if they do produce what I need. And so 8 from one triangle corresponds with 3 to the other. So you can say they match up, and you can say that these match up. And so I get 8 over 3 and 8 over 3, and of course they are proportional to each other. And I make the mental note that even if I had made the sides that I labeled 8 any other number, like 10 and 10 or 12 and 12, and then made the bottom two numbers anything other than 3, like 2 and 2 or 5 and 5, it would always produce a proportion that would work. So that's good news for me. So my answer is it is SAS, and it's triangle ABX. Alphabetical order. Second triangle, what coordinates with A? Well, I've got, the way I shaded it is R, and B corresponds to C, and X corresponds to itself. So that's if I matched it up that way, but it does occur to me that it could be written as CRX, and that would be fine too. But as long as you get one relationship that makes sense to you, that's great. All right, number 6. Ooh, we have 2 equilateral triangles. Well, I'm suspicious of side, side, side. Hey, maybe I can do what I did before. I'll even use the same numbers because it makes sense. 8, 8, and 8. 3, that's supposed to be a 3. 3 and 3. So that means I would have 8 over 3, 8 over 3, 8 over 3. And of course, they are all equal to each other. So we do have similar triangles, and it's by SSS and triangle ABC. Now here's where it gets interesting. It doesn't really matter because A could, as long as it matched up with another 60-degree angle, as long as it matched up with an angle who are between 2 congruent sides, we're good. So A could match up with X, A could match up with Y, A could match up with Z. It doesn't matter. They're both equilateral triangles. I can spin that little triangle and have it correspond to whatever vertices I want it to. So B could correspond to Y and C could correspond to Z. I could have Y, X, Z. I could have Z, Y, X. And I think there's a few more. But as long as you know that they're similar because of SSS, we're all good. That concludes the top 6. Let's go down to the bottom. Here they want you to solve and find the value of X. Okay. Now if they just said find the value of X and just gave me 2 any triangles, you know, out of context, I know we're in the similar triangles unit, but say, you know, this was on the midterm, and you know the midterm covers everything we've ever done this year in geometry, and I just flash 2 triangles up there and say, hey, find X, how do you know which method to use? Well, looking at the diagram, I can tell they probably don't want you to think that these are congruent triangles. Because if I look at the side that has 6, it's between two marked angles, one with a swoop and one with a box indicating it's 90 degrees. If I find the side that corresponds to that side, that would be 9 in the other triangle, and there's the box and there's the swoop. So they're not congruent, otherwise those would have the same value. So I don't need to use any congruent methods here. So now I'm wondering if they are similar. You know, they look like the same shape, different sizes, and that should ring a bell. So I know I have 3 ways to prove if they are similar. So I've got 2 angles of one triangle congruent to 2 angles of another triangle. So yes, they are similar, and I can set up a proportion and solve. So that whole long explanation was basically to show that yes, they are similar triangles, and we're going to use the proportion to solve this. We kind of knew that already because this whole sheet is about similar triangles, so it's no surprise. I'm going to once again mark these 2 to correspond to each other. I already explained that both 6 and 9 are represent the length of the side that's between the right angle and the set of congruent angles. So that means 6 must coordinate to 9. So that can be one part of the proportion. Let's go on to the other marked sides. 5 is another leg. It's not the hypotenuse. X is another leg. It's not the hypotenuse. So they must coordinate. So I put 5 over X. So if I cross multiply, I don't think this is going to give me a pretty answer, but I'm going to follow the steps regardless. If I cross multiply, I get 6x equal to 45. At that point, I can go to my calculator and do 45 divided by 6, and I get 7.5. And that's my answer. Like I said, it's not pretty, but it's an answer. So I'm running down into the other problems. So what I'm going to do is I'm going to work 7, 8, and 9, and then I'll erase what I need to erase so I can work 10, 11, and 12. Let's look at number 8. Number 8, the first thing I tend to look for is the side that has the variable on it and try to figure out what that corresponds to. So instantly I have x over 11. So that's kind of nice. 10 is less than 15, so let's focus on that one. And 8 is less than 12, so I'm going to match up these 2 smaller sides together and come up with the other side. So the 10 came from the triangle with the x, so that's going to go on the top, and the 8 came from the triangle with the 11, so that's going to go in the bottom. And now I can cross multiply. And I get 8x equal to 110. Once again, I can go to my calculator, do 110 divided by 8, and I get 13.75. Number 9. Once again, I always look for the x and where it is and what it corresponds to. And it corresponds to the 12 in the other triangle. So now I'm going to go from left to right. So I know that 12 over x is a valid ratio. And I'm going to set up my proportion. And I see that I have some other sides labeled here, and they do coordinate with each other because they're both the shortest lengths of each of the triangles. So 7 is going to be over 4. If I cross multiply, I have 7x is equal to 48. And if I do 48 divided by 7, I get an irrational number. It looks like 1, but it's not. I'll get into that later. Anyway, it's 6.857, we'll say. And I can circle it and be done. Of course, you always want to pay attention to what you should round decimals to, or you can look at your answer choices if it's multiple choice and see which one matches up. Okay. And just looking at the decimal again, I see that it's not an irrational number, which makes sense because all rational numbers can be formed to be a fraction, and 48 divided by 7 is a fraction. And so it is a repeating decimal. It just doesn't repeat until it looks like the 1, 2, 3, 4, 5, 6, 7th decimal place, because it's 6.857142, 857, 142, 857, 142, and so on. So it is a repeating decimal. All right, so I've done 7, 8, and 9. And hopefully you were able to pause it and get that down, or you're ready to move on. So I'm going to erase everything that I've done so far so that there's room down at the bottom for me to do the next set of problems. All right, for number 10. Ooh, I see a smaller triangle inside of a larger triangle. So I am going to separate these out. There's my larger. There's my smaller. So if I label them, I have the 12, I have the 15, I have the 17. If I go down, ooh, interesting. How do I figure out what this whole length is? Well, I just take the 12 and the 8 and add them together. So I know that whole length is 20. Do the same thing with the other side, then I know this whole length is 25. And then down at the very bottom is the x. So one of the techniques that you can use here when you see overlapping triangles is to separate them out and draw two separate triangles, label all the sides, and then you might be able to set up corresponding sides a bit easier. We do know by looking that the x is down here and it's going to correspond to the 17 up there. So I know one part of my proportion can be 17 over x. All right, to look at the other, I know that the 12 is going to correspond to the 20, and those are the smaller numbers. I could use 15 over 25, but I'm going to keep things a little simpler. 17 came from the top, so I'm going to put 12 on the top and then put 20 in the bottom. And now I can cross multiply and solve. Now, I do notice that this 12 over 20 could be simplified, and it might make my life a little bit easier. So this whole proportion could be simplified to be 17 over x is equal to, and if I divide top and bottom by 4, that would give me 3/5. Now when I cross multiply, I'll get 3x is equal to whatever 17 times 5 is, which is 85. And then I can divide 85 by 3. And I get 28.3 repeating. My only complaint about this handout is that it doesn't have a whole heck of a lot of room for work. So we make do with what we've got, or we use extra sheets of paper so we can keep our work organized. For the purpose of this video, I'm doing it all on one sheet so you can see it, but it does make my work go a little all over the place. So now that you've had time to absorb that, I'm going to erase the stuff around number 11 so that you can see clearly how to do number 11. So we're on number 11. Once again, we have a smaller triangle and a larger triangle, and I can separate those out. I think this time I'll put them on this side. So I have the smaller triangle with the 4 and the 3. And then I have the larger triangle. And let's see if we can figure out what goes on here. Now, I can definitely see that the 8 represents this side down at the bottom. But what do I put on the right over here? Well, one of the most common mistakes that I see is that people will think that this side is 4x. But that's not what we did with the other triangle in number 10. We took the 15 and the 10 and we did what? We added them. So it is not 4 times x, it is 4 plus x, representing that whole length. So from here I can set up my proportion. I've got definitely the 3 to 8 taken care of. So I'm going to write that over here, 3 over 8. And then I have my 4, and I know that goes in the top, and it coordinates to the 4 plus x that we just figured out. Not as simple of an equation that we would have preferred, but it is going to get us the correct answer. When we cross multiply, it is very important that you remember the parentheses, because you are going to have to distribute. You're going to have to distribute that 3 into the 4 and the x. So that's 12 plus 3x is equal to 32. If I subtract 12 from both sides, I am going to get, and I'm going to carry this down here, I'm going to get 3x is equal to 20. Scrolling a bit. And if I divide both sides by 3, I'm going to get 6.6 repeating. And that is the answer to number 11. Once again, working on this problem led me all over the page, which made it a little discombobulated and everything. If I had designed this worksheet myself, I would have put a lot more space or required myself to do the work on a different page. All right, so I'm going to erase all this so that we can do number 12. Number 12, allocate the x. And it is going to correspond with the 12 down at the bottom, so I can set up x over 12. And then I look and I see that the only other sides given to me are the 42 and the 14. So there's the proportion I can set up. I can cross multiply. I get 14x is equal to 12 times 42. 14x is equal to 12 times 42 is 504. And I can divide both sides by 14. And I get x equal to 36. So the answer to this one is 36. Finally, that leads us to the last problem on the page. And let's see what's going on. Natasha places a mirror on the ground. This makes me think of similar triangles. This is a very popular problem that you will see when they want you to use similar triangles and proportions. So as soon as you see somebody placing a mirror on the ground and coming up with a diagram that looks like this on the right, you're looking at similar triangles. So we got a base of the oak tree. She walks backwards until she can see the top of the tree in the middle of the mirror. At that point, Natasha's eyes are 5.5 feet above the ground, and her feet are 4 feet from the image in the mirror. Find the height of the oak tree. So basically what this little story just did is it let me move my diagram over. How about we put it over here? It'll make more sense. Is it described the picture that it had already drawn for you. We got Natasha, we have a tree. We have Natasha looking down at a mirror and seeing the top of the tree. And they're both right angles down here. And Her eye is 5.5 feet. She's standing 4 feet away. The tree is 24 feet away from the mirror, and we're looking for the height of the tree. So here's my simplified diagram of what's going on in this problem, and let's see what we've got. So I find my x. The x is over here, and it corresponds to the 5.5. So I can set up from left to right, 5.5 over x. And then I have the 4 corresponds to the 24, and if we're going still left to right, 4 goes in the top because it's from the left triangle, and 24 goes on the bottom because it's from the right triangle. So I'm keeping the same order. I can cross multiply for x, and (24) times 5.5 is 132. If I divide both sides by 4, I will find that x is equal to 33. Putting our units, the tree must be 33 feet high. So that was a very thorough explanation of every single problem on this homework page. I hope that it helps somebody out there. And now I'm going to sign off and see what else could be helpful for you guys in preparing for the midterm.